Hello and welcome to this video tech tip. I'm Scott Craner with Imaginet Technologies. In this session, we'll be reviewing the Traverse editor available within Civil 3D. We're in Civil 3D 2020. To open the Traverse editor, from the Home tab of the ribbon, go to the Create Ground Data panel, then to the Traverse pull-down, left-click. Notice there are two options, Traverse Editor and Traverse Adjustment. We'll be discussing the Traverse Adjustment tool in a separate video tech tip. For now, I'm going to left-click Traverse Editor, and the tool opens at the bottom of the drawing area. First, let's take a look at the top of this tool. This is where you control files, options, and settings. Moving from left to right, first you have the New icon, which creates a new Traverse Editor file. Then you have the Open icon, which opens an existing file. This opens either a TRV2 file, which is the current Traverse Editor file format, or a TRVX file, which is the Coordinate Geometry Editor file format. Next is Load from Entity. This allows you to load a traverse from a polyline within the drawing. Then you have Save, which allows you to save a traverse file in the TRV2 format. You also have Save As, which allows you to save out to a file of a different name than the one you're in. You have the Load Balance tool. We'll cover this tool in a separate video tech tip, but this allows you to perform a traverse adjustment on a traverse. Next, Points and Lines. This allows you to control what elements are placed in the drawing from the Traverse Editor. You can put points and lines in, points alone, or lines alone. Next is the Zoom setting. You can set it to Zoom Extents, which will zoom to the entire extents of the traverse as you're creating it. You can set it to Zoom Current Row, which will zoom into the element that you're creating or to the element that's highlighted in the Traverse Editor table once you've already created a traverse and you're editing it, or you can set it to no zoom. Next, you have the Lines and Arcs. Unlike the points and lines, this is not controlling elements that are placed in the drawing. This is controlling your inputs. Your options are Lines and Arc. When it's set for Lines and Arc, you can see your table is set up to put in both line and arc information. If I change this to lines, it changes the table to only take line input. So if you're going to be creating a traverse that includes arcs, you need to set it to lines and arcs. The next icon is for settings. When I left click it, it opens a dialog box. Let's go through these settings. The top is for labels. This, when checked, automatically adjusts the scale of the annotation to fit the length of the element in your traverse. Next is for direction. This is actually for controlling angular inputs. You can either set it to decimal, degrees, minutes, and seconds, or straight decimal format. The next is for point conflict resolution. Your options are create a Kogo point or overwrite the Kogo point. And the last is for controlling the erasing of the graphics placed in the drawing. You can control them either erasing when creating a new traverse, when opening another traverse, when loading a traverse from an entity, or closing the Traverse Editor. You can set each one of these independently or set none of them and erase elements in the drawing manually. The last icon is for Help. This opens help specifically geared to the Traverse Editor, and it is very useful. Pretty much everything you need to know is right here in this help file. Let's take a look at one of the easiest ways to enter a traverse into the Traverse Editor. We have a polyline in the drawing. We're just going to come down here to the Load from Entity tool, left click, then come up to the drawing area, select within it, and then select the polyline. Notice once it's selected that the elements are annotated, so you can see all of the lines and arcs, and the Traverse editor is populated. Also notice when I select one of these lines down here, for instance line 3, that it highlights that element in the Traverse in the drawing pane. So as I go from line 2, it's highlighted, to line 3, to the radial arc in line 4, to line 5, notice how the information is highlighted in the drawing window. Next, we're going to start entering Traverse information down here in the table. But before we get into that, I want to just take a moment to show you where the format and the precision that affects not just what's entered here, but more your adjustments and your reports that are output from this. If I go to Settings in Tool Space, select the drawing name, right-click, and go to the Drawing Settings, Edit Drawing Settings. Ambient Settings is where the precision and format are set. If you want to come in and change your precision, your distance precision, you can do it right here. If you want to come down to the angle and change either your precision or your format, I'm going to leave the precision at 4, but I am going to change the format to degrees, minutes, and seconds spaced. That's how I want it to appear in my reports, and I'm going to click OK. Now let's look at entering some data into the Traverse editor. The first thing you'll notice is that there is already a row, and the first column is side, and the side type listed is point. From the pull down you can see I can't change this. The first side needs to be a point. It's the point of beginning, and that can be a point number. It can be northing and easting or X and Y coordinates. I'm going to just click here and select a point in the drawing. And you can see that the point is input, northing and easting, and it gives it a name. Since I've already got a point 1 and a 2, it gives it that next point name, which is the number. There's also a column here for angle. This is optional, but if you wanted to put in another element like a line that relied on a backside or a foresight, you would need to put in an angle here. And to show you that, I'm going to go ahead and enter an angle just using a capital W for the west direction. That's just a primary direction. And you can see that kind of displays up in the drawing. So on the next line, I'm going to show you that I can change this to a point, a line, a chord arc, radial arc, or side shot. I'm going to set it at line, and I'm going to enter the angle here as a turned angle. And that turned angle is going to be left 45, 12, 26. And I'm going to put in a distance of 250 feet. And you can see that that turned angle there, let me zoom into it, has been turned from a foresight. If I come down to this angle and I remove that L to designate a turned angle, and I make this just a straight angle, see how that changes the angle. This is no longer turned from a foresight, but it's using that west angle and turning from a backsight. Now, since I want this to be from a foresight, I'm going to add my L back in and keep on adding elements. I'm going to zoom out here a little bit so you can see my points 1 and 2. And the next line I'm going to add, I'm going to use those points. And I'm going to use a special entryway to do those. I'm going to type in point 1, then 3 dots, and point 2 for the angle. And I'm going to do the same thing for the distance. 1, dot, 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 2. And you can see, even though it zooms to extents, I'm going to set this to no zoom so it doesn't keep zooming on us. That direction and distance is based on these points. Furthermore, if I take one of these points and move it, the line updates. So this is dynamically linked. This is a good opportunity to open the help and take a look at some of the ways you can enter angles and distances. So let's do that. As I scroll down here in the help file, we've got the angle entry types. We can use directions, primary directions, north, south, east, or west. You can enter them just with the first letter, or you can spell them out. Directions and angles can be bearings or azimuths. North 30 west is an example of a bearing. North 45 is an example of an azimuth. You can use quadrant and angle with a dot dot format. For instance, this 1 dot dot 45, the 1 represents the quadrant, and then the 45 the angle in that quadrant. So you've got 4 quadrants, and it's very easy to enter a quadrant and angle that way. You can enter a right or left turned angles with the R and the L. Note that these angles are turned from a foresight. You can enter degrees, minutes, and seconds. If you space the degrees, minutes, and seconds, it will always be interpreted that way as degrees, minutes, and seconds. If you have the drawing set, your Traverse editor to set up to interpret decimal degrees, minutes, and seconds, you can type it in the decimal degrees, minutes, and seconds format. 63.5125 would be interpreted as 63 degrees, 51 minutes, 25 seconds, if you have it set that way. If you have it set for decimal degrees, you can type in the decimal degree as a straight decimal, not in minutes and seconds, just a straight 63.8569 degrees in a decimal format without minutes and seconds. You can do that if you prefer, if you have it set up in your drawing that way. You can also use the angle between 2 Kogo points the way I just did, using the first point number, 3 dots, and the second point number. You can also pick locations in the drawing, just like I've shown you here in the initial part of this demonstration. You can also use mathematical equations, and the operators available are the plus sign, the minus sign, the / for a divide, and the asterisk for multiplication. For distance, you can enter numeric values. If you want to change the units, there are unit overrides. For instance, if you're in a drawing that's set to feet or U.S. survey feet, you can override that with meters by typing M after the numeric entry. If you're in a drawing that's set to metric and meters, you could override that by typing the foot symbol as an override. You can also enter Kogo points, just like I did in the example before we got into help, where you used the triple dot method, just as I did. You can also select locations in the drawing by clicking, and also mathematical equations. The same operators for distance apply. Now let's take a look at some of these other numeric operators you can use for overrides. You can use the foot symbol to override the feet when you're not in a drawing set for feet. You can use the M, as I indicated, for meters, C for chains, R for rod, V for Vera, which is common in Texas, and that Vera is 33.13, 33 1/3 inches, and you can use an L for lengths. Right under this, there's a little table that even tells you, based on the drawing units set and the imperial to metric conversion set in the drawing, what suffix results in what kind of conversion. So it specifically tells you what it's going to convert to with these suffixes, so you don't get confused about whether you're going to U.S. survey feet or international feet. So this tells you exactly what to expect. All right, let's continue around our traverse. Let's go ahead and set a chord arc. To do that, I'm going to change this type from a line to a chord. The next thing I want to do is set my angle, and I'm going to set this as a primary direction. I'm going to set it south. And then I want to set the distance of that chord to 125 feet. Next, I want to set a radius, and I'm going to make the radius 100. Let me go ahead and change the zoom to zoom into it, and you can see that that chord is going in the south direction, that it's got 125 feet in length, and that I've set a radius on that of 100 feet. Notice that the radius is regular text. It also calculated a delta angle and a length, and those are both in italicized text. That's to indicate that they're calculated, not entries. If I came over here and entered a length of 140, then it would change to regular text, and the delta angle and the radius would be italicized. Let's go ahead and return that to 100 feet. And next, let's put in a line by selecting in a drawing. To do that, I'm going to select the angle and pick it in the drawing. Notice it automatically populates a distance. If I want to change that distance, I can pick that also in the drawing. Since I'm selecting here in the distance field, it's not going to let me change the angle. Notice that the angle won't change. This 68, 42, 24 won't change, but I can change the distance. If I want to change the angle, I can come back here and select again. And if I do that, the distance won't change. So initially it sets both, but after that, if you go back and try to edit it, it edits them individually. You can either edit the angle or the distance, but they edit separately. Okay, let's try to put in some different types of arcs. We're going to put in a radial arc. We're going to make it tangential, and to do that, we're going to turn it from this previous line by using a right 90 radial and a radius of 175 feet, a delta angle of 35 degrees, and it puts in our radial arc. Let's put in another arc, a radial arc. Let's make this one a compound curve. So for the radial, I'm going to put in 0, since we want it to be on the same radius line. Let's change the radius to 115, and the delta angle, let's make it 25. And you can see, as I zoom out here a little bit, that this is a compound curve with a different radius that is tangential to the previous radial arc. If we want to put in a reverse curve, it's similar. The entry is a little tricky. I'm going to start again with a radial arc. For the radial, I'm going to put in 180 because we're going to actually be wanting the radius point to be 180 degrees out from where we are now. If I want to set this to 150 radius, The trick to this is the angle. I need to set my angle, the delta angle, to a negative value. And let's set this to -35. Again, I'll zoom out and you can see we've got a radial arc, a compound curve tangent to that, and then a reverse curve tangent to that. To end this, I think what I'm going to do is select this last line by just selecting points in the drawing. And that looks good. And just to change this up a little bit, if I wanted to edit this entry that's in feet, which is what the drawing is set up for, US survey feet, if I wanted to enter that as meters, say 25 meters, the entry goes into the Traverse editor as meters, but it's converted to feet, 82.02, just like I showed you in the help. So you can override the entry, but it still shows up in the drawing in the units set in the drawing. Now that we've entered data into the Traverse editor, let's look at how we can remove a little information. This last line that I entered, if I select that, right click, say I want to redo this row, I can just delete that row and come back down here and say I want to pick it in the drawing. Turn on my O-snaps and close it. Let me right click again here in my table and let's look at these just briefly. You can insert rows before or after, delete a row, move rows up or down, copy to the clipboard, or copy selected items to the clipboard. So these are your right click options. All you do is right click in the table and these come up and they act on items based on what you have selected in here. Once you have your Traverse closed or edited to your satisfaction, you can save it. You can save it. Since this one's not been named, I can just save this out. It brings up a dialog box to let me save it to a TRV2 file, and I can name this complete and save it. When I'm all done, I can close the Traverse editor. If I open a new drawing, open the Traverse editor, and if I want to get back into that Traverse, I can just reopen that up by selecting my complete Traverse and opening it. And I can set the zoom to zoom extents, and you can see my completed Traverse in a new drawing. I hope you find this information helpful. Thank you for watching.